gentlemen, may I have your attention, please?
Today we're learning 8-6, radical expressions and rational exponents. Remember, key point in this lesson. Perfect cubes are 1, 8, 27, 64, 125, 216. And also, perfect fourths are 1, 16, 81, 256, and 625. Here are the beginning of this 8-6 lesson. Types of real roots. The odd power is one real power. And it is positive or negative. And our first example is cube root of 8. Nick?
69.
Okay, no. How about Luke?
Well, I believe the answer is 2.
Good job. The answer is 2 because 2 times 2 times 2 is 8. Alright, the next problem is the cube root of 64. And that answer is 4 because 4 times 4 times 4 is 60. So in the even powers, it has the positive radicand. So that's a positive number inside the radical as shown here. And this has 2 real roots. For our first example, it is the 4th root of 16. So then this means whatever number 4 times 4 times is equal to the number, which is plus or negative 2, because it could be both because it's positive radical. The next example is the 4th root of 256. As the last example, you have to think of whatever number 4 times is equal to the solution, and that is positive and negative. The even power with the negative radicand is the negative number inside of the radical, so that there's 0 real roots. So the first example is the 4th root of negative 16, and all solutions in the even power with the negative radicand is no solution.
Some properties are n radical AB, to make it easier to split it up, is n radical A times n radical B. An example, the cube root of 54 is cube root of 27 times the cube root of 2. This simplified, right? And this can't be simplified, so you bring it down. So your answer is 3 cube root 2. Another property is n root of AB. To simplify it, you have to take the n and distribute it, so it'd be n root of A over n root of B. An example, cube root of 64 over 125, simplified is cube root 64 over cube root of 125 is 4/5.
Yeah, Jacob?
Can I have a pencil hat?
I don't have any pencil hats, I only have eraser marks.
Can I have an eraser pen?
Properties of exponents. When you're multiplying exponents, you add the exponents. When you have a number raised to a power and multiplied by an exponent, you multiply both the exponents. When you have exponents that you're dividing, you're subtracting. When you're multiplying two numbers together by a fractional power, you distribute the fractional powers to A and B. And when you're dividing by a fractional power, you're distributing again to both A and B. Properties of exponents. Examples. Number 1, 16 to the 4th is times 16 to the 1/5. You add them. So it's going to be 5 more 5 is that's going to equal 1. So 16 to the first is 16. Properties of exponents. Example number 2. When you have 27 to 1/3 over 27 to 2/3, you have to subtract your exponents. So
He changed our shape
Alright class, today we are doing lesson 8-7, radical functions.
Just a reminder, when you're looking at a function, A is the stretch or compress, x minus b is the left or right, and k is up or down. When you're looking at functions, the square root of negative x is a reflection over the y-axis. And then if you're looking at another function of the square root of x, it is a reflection over the x-axis.
Examples are y equals the square root of x, y equals the cube root of x, and y equals the square root of x plus 2. Now let's go outside and find some real-life examples of radical functions.
Do you know the definition of a radical function? Excuse me, sir. Do you know the definition of a radical function?
Well, actually, a function is whose rule is a radical expression.
Oh, thank you. Now that we know the definition of a radical function, we can start the problem. Wait, stop the car! There's something in the road! Whoa, it's a radical function! No way, we have to solve this. First, we'll make an XY table. The x values should be perfect squares, so when you plug them into the equation, they come out as all real numbers, so it's easier to graph. No, not over our math! Stop! The domain is all the x values. The range for this function is y is greater than or equal to 0.
Oh my god, look! It's a radical function. I have to solve it. The first step when graphing the function, the cube root x plus 2, is making an xy table. You want to find numbers to put in the x side that, when added by 2, it makes a perfect cube. So I picked -10, and when you plug it into the function, you get -2. I picked -3, because when you plug it into the function, you get -1. -2, because when you plug it into the function, you get 0. 0, and you get 2, 6, and you get 2. Then you use the xy table to graph the function. I graphed the function ahead of time, so you can see -10, -2, -3, -1, 2, 0, 0, 2, and 6, 2. It comes out as this line. The final step when graphing a function is finding the domain and range. When you have the cube root of anything, the domain and range are always going to be all real numbers. And for the coordinate for the domain, it's negative infinity, infinity.